All right, so number 21 from page 153 or 154. A ladder 25 feet long is leaning against the wall of a house. See the figure. The base of the ladder is pulled away from the wall at a rate of 2 feet per second. It's pulled away. It's not like slipping, like somebody is intentionally pulling the ladder away. All right, but the ladder's 25, so that's fixed. That's not changing. We can label that 25. This is moving away at 2 feet per second. Part A, how fast is the top of the ladder moving down the wall when its base is 7, 15, and 24 feet from the wall? So it's really 3 questions in one for part A. We'll answer one of those questions. We'll do the when A is 7 feet. And A equals 7. Find how fast is the ladder moving down the wall. Well, I need a letter for that. So let's call it B. I'm also thinking ahead here. This looks like an A squared plus B squared equals C squared problem. So let's just go ahead and use those. So when A is 7, find how fast that's changing. So let's call that dB dt. And what's this 2 feet per second? What's that equal to? Or what is that in terms of the variables in our problem? dA dt. That's how fast A is changing. And is it positive or negative? Positive. It's getting bigger. How about when we get an answer for dB dt? Is it going to be positive or negative? It should be negative because the distance is shrinking. All right, just checking to make sure I got everything right. Ladder is 25 feet long. Wall of the house. The base of the ladder is getting pulled away. How fast is it moving down when A is 7? All right. Again, you don't have to write this, but if it helps you think through the problem, draw it. We did that. Translate into math symbols. We did that. Again, those usually kind of go together. An equation that would tie all the pieces together would be A squared plus B squared equals C squared. And then let's take the derivative of that equation. 2a dA dt plus 2b dB dt equals 2c dC dt. And we're trying to find dB dt, what we're looking for, which means I'm supposed to know everybody else in order to make this work. A is 7, we know that. dA dt is 2. I don't know B, although when A is 7, anybody recognize that triangle? If you don't, you can do A squared plus B squared equals C squared and figure out that B is 24. 7, 24, 25. So we know B. We know C, that's 25, that's always 25. We don't know dC dt, or at least we haven't said what it is, and they haven't told us what it is. What's dC dt? Why is it 0? It's not changing, it's a constant. So dC dt is 0 because it's a constant, it's not changing. Alright, I could divide everybody by 2 first, or I could leave them in there. Doesn't matter. I'm going to solve for dB dt first. So I'll move A dA dt over, and then I'll divide by B. Oops, that would make it negative. Which is good. We thought it would be negative. So I subtracted 2A dA dt over, and then divided by 2B. And 2's canceled out. negative, A is 7, the ADT is 2, and B is 24. And the units, B is a length, so that's feet. T is time, and for this problem, time is in seconds, so feet per second. And that's a perfectly acceptable answer that we have right there. No need to mess up simplifying a fraction when you don't need to. Although on a multiple choice test, it probably would be reduced. Let's see, we already said it was negative. That makes sense because it's getting smaller. All right, the other parts of numbers of 7a are do that for when a is 15 and 24. But we're good on that. Let's hold off on that. Let's just jump to B and C. Part B. Consider the triangle formed by the side of the house, the ladder, and the ground. Okay, triangle formed. Yep, got that. Find the rate at which the area of the triangle is changing. So find the ADT when the base of the ladder is 7 feet from the wall. Okay, that's why I picked the 7 to do, because the rest of the problem has to do with 7. So, DTEDs again. Draw it, translate it, we already did that. I do need an equation with area. Area of a triangle. 1/2 base times height. Or for us, 1/2 A times B. And is there a way to get around the product rule here? I don't think so, because A and B aren't always related to each other the same way. There's not like A is twice of B or A is half of B or any of that stuff. And I know dAdt and dBdt, so I think I'll be fine to do a product rule here because it's going to give me a lot of pieces, but I have all the pieces. So dAdt equals, I think I'm just going to stick the 1/2 out in front. And product rule in place here. The first one times the derivative of the second one plus the second one times the derivative of the first one. That put a lot of variables in play, but I think we know all the pieces. We know A and B, we know dAdt, and we just found dBdt. So we've got all the pieces here. 7 times -7/12 plus 24 times 2. Wait, I'm looking for all my pieces here. dAdt is 2. And that's a good enough for my answer, right? Like, don't, why risk doing something dumb in there? Just leave it. It's calculator ready. You're good with that. Area is feet squared. Time is in seconds, so feet squared per second. And again, I'm not messing with cleaning that up because I don't need to clean that up. Questions on that one, or that part of that one? Part C, find the rate at which, it's a good problem, got lots of stuff in it. Find the rate at which the angle between the ladder and the wall of the house. The ladder and the wall of the house. Okay, so that's not this angle of elevation. That's the ladder and the wall of the house. That's up here. Find the rate at which that angle is changing. So find the theta dt when the base of the ladder is 7 feet from the wall. So again, when A equals 7. So I need an equation that has theta in it. So I'm thinking SOHCAHTOA going to redraw the picture here just so you can see it on the screen at the same time. All right, I'm going to argue there's 2 good choices and 1 terrible choice. Although it would still work, it would just be a terrible choice. All of them work. Which one should we not use? Which is the bad choice? Tangent. Why is that a bad choice?
No values.
And you got 2 things that are changing. So I know both of them and I know how they're changing, so I could do it. But it'd be really nice to use the hypotenuse since it's not changing. So now it doesn't matter because I know the opposite. I know how opposite is changing. I know adjacent. I know how adjacent is changing. So sine and cosine are going to be about the same. Which one do you want? Oh, heard one of each. Why cosine? Just cause? Thomas, why sine? Okay. Nobody's got a good reason for either one, and that's fine. I'm going to pick sine. So sine of an angle equals opposite over hypotenuse. Since hypotenuse isn't changing, I'm going to write over 25. I don't have to worry about the 25 changing. That's a fixed, constant number. I mean, the ladder's changing positions, but it's not changing length. So derivative of sine is cosine times d theta dt equals 1/25. If I view the 25 as a 1/25 dA dt. And I know dA dt. Looking for d theta dt. I don't know the cosine. I mean, I haven't identified it yet. It's easy enough to know it because the cosine is equal to adjacent over hypotenuse. So for this angle in this triangle, cosine is 24 over 25. And the ADT way back at the beginning was equal to 2. So I'm almost done. D theta dt equals 2 over 25 times 25 over 24 to make the fraction go away. And just because it's an easy one, I'll say that that's 1/12. Units of angles are always radians. Time in this problem is seconds. 1/12 radian per second. There's really no way to have a feel for if that's a good answer or not, except for the plus and minus thing. So according to our answer, is the angle getting smaller or larger? It's getting bigger because it's positive. The change is positive, so it's getting bigger. Does that make sense for this ladder sliding down the wall? Yeah, when it gets down here, that's a bigger angle. So it at least makes sense, the positive negative thing. I mean, really tricky to figure out if 1/12 makes any sense or not. I don't know. But it at least makes sense that it's positive. All right, so that had a ladder in it. That had an angle in it. So that's a really good problem to make sure you understand for the test.